distant thunderstorms.
Right.
You might be able to see and capture red sprites.
Whoa! I saw that one too.
I saw that one.
You saw that red one?
Yes.
Sprites are large-scale electrical discharges occurring high above thunderstorms in the upper atmosphere.
Bam, there's a sprite. Bam, bam, bam. They come in clusters.
They are massive events. Sometimes 50 kilometers tall by 50 kilometers wide. They belong to a mysterious and colorful group of phenomenon called transient luminous events, or TLEs. Other TLEs include halos, elves, secondary jets, blue starters, blue jets, and the magnificent gigantic jets. But what exactly are these transient luminous events, and how do they form?
Yes!
Of red sprites, as well as showcasing some of the most rare and amazing captures ever recorded. It is much like the process that causes the auroras. Reds and blues, depending on the atmospheric pressure and other physics. Auroras occur way higher than sprites, up around 100 to 500 kilometers in altitude, where the atmosphere is mostly molecular oxygen. As mentioned earlier, the excitation of oxygen emits green light, and that's why the auroras are mostly green. But in some really strong auroral events, you can see pinkish fringes along the bottom edge of the green aurora. And that's usually where the high-energy particles from the sun have penetrated way down in our atmosphere, where there's an increasingly higher percentage of nitrogen, right around the 100-kilometer altitude, right around the top edge where sprites reach. Sprites occur around 40 to 100 kilometers, and at these altitudes, the atmosphere is mostly nitrogen. Remember earlier that the excitation of nitrogen emits blues and reds.
Right.
At the atmospheric pressure sprites occur, nitrogen excites red, but as the pressure increases the closer you get to Earth, nitrogen excites more in the blues. Altitudes where nitrogen excites more red. In a photograph of a sprite and secondary jet event, you can see the gradual transitioning from blues to reds as the pressure quickly decreases in altitude.
I'd like to send a colossal thanks out to Paul.